Okay, good afternoon. My name is Stéphanie Guinehut. I'm going to talk about the Global Multi-Observations MFC that deal with 3D gridded time series. And this activity is a partnership between CLS here in Toulouse and our Italian colleague CNR from CNR. And this presentation has been prepared with the help of Sandrine Mullet, Nathalie Verbruge, and our Italian colleague Bruno Bongiorno Nardelli. I will start with the presentation of what is GlobeUps. So GlobeUps is the multi-observations component of CMEMS. It is based on the combination of satellite and in-situ observations using statistical methods only. There's no dynamical model behind, and it provides global three-dimensional temperature, salinity, and geostrophic velocities field at a monthly or weekly time period on a 1/4 of a degree horizontal grid and for the first 1500 meter depth of the ocean. We provide a reprocessed data set covering the 1993-2014 period and also near real time. And very soon, in April next year, we will also provide a dedicated product for surface salinity and density fields. Really the main idea behind our system is to take advantage of the strengths of the two main components of the global ocean observing system, which are the sparse but having the vertical resolution of the in-situ observations and the high resolution in space and time, but or integrated or having an observation just at the surface satellite fields. And the main idea also is to stay very close to the observations. So we will see in a minute with the description of the method that we're going to use observation from the in-situ TAC that has just been presented by Tanguy, and also from the sea level TAC that has just been presented by Yanis, and also from sea surface temperature that will be just presented afterwards by Simon. Here it's an overview of the method. The method that is used to compute the 3D field is a 3 steps method. So we start with the climatology field, and we use a multilinear regression method to project onto the vertical the information provided by the satellite. For temperature, we use altimetry and also sea surface temperature, satellite observations. And for salinity, we use only, for the present time, information from altimetry. And here you have an example of the temperature that is computed from this method at 100 meter depth. This is expressed as anomalies from the first guess climatology. And we can see that we have many mesoscale structures that are in fact provided by the satellite fields. So here, really, the key information is that the satellite observation provide the mesoscale part of the signal. Very soon, in April next year, we will add an additional forcing field to reconstruct salinity at depth with a specific sea surface salinity. So we will have a new salinity at depth computed using satellite altimetry, but also satellite, a specific sea surface salinity product. Then during the second step of the method, we combine the synthetic estimate with all available in situ observation using an optimal interpolation methods. And here the optimal interpolation method is here to correct for the large scale bias that has been introduced during step 1. Here, for example, with the synthetic estimate, we can see that we have less cold temperature than what is present in the in-situ observation. And we can see that the combined field has been corrected and it's much more closer to the in-situ observations now. And as I said, our method is a 3-step method, and during the third step, we use the thermal wind equation method to compute geostrophic currents. By combining the combined temperature and salinity field with estimate of sea level anomaly, again from altimetry, and an estimation on the mean dynamic topography. And then here you have an example of the geostrophic current at 100 meter depth. A few words on the new product, specific product for the surface, sea surface salinity and sea surface density, coming again only using observation and statistical methods. This product starts with the first guess from the Cora OI field that Tanguy has just described. We use a multivariate optimal interpolation method, and we introduce information from satellite sea surface temperature and in situ sea surface salinity and sea surface density field. And the main hypothesis behind is that sea surface temperature and sea surface salinity and density are correlated at scales smaller than the ones dominated by atmospheric variability. And you can see here the resulted sea surface salinity field for a specific date. Started from the OI, introducing some mesoscale fixture and some fronts coming from the sea surface temperature, satellite sea surface temperature, and also having some information from the in situ. Now some applications, what we do with our fields. This is only illustration. I'm not going to go very much into detail, but it's just to give you a flavor what can be done with our fields. So two main applications. The first one is from observing system evaluation, and the second one is from ocean state estimate. So a study about observing system evaluation that has been carried on to assess the impact of the in situ and specifically the Argo observing system to map temperature and salinity fields together with satellite observation. So this study has been carried on during the EMS FP7 project. And the tools that have been used is the GlobeUps systems and degree of freedom of signal diagnostics that provides a measure of the gain in information brought by the observations. Part of the results have been published in this paper, and I give you just a very quick example. So here you have two metrics. The first one is tells you from which observing system the information comes from, and the second one tells you if there is redundancy inside a specific observing system. And the illustration is done for the temperature at 100 meter depth for a specific snapshot, the 4th of June 2008. And the observing system has been separated into three. The first one is the Argo observations only. The other one is the other observing system, other in situ, observing system. And the third one is the satellite and climatology, which means the first step, the synthetic field, the first step of our methods. And here, just very quickly, what we can see is that most of the information in our method comes from the Argo observing system, more than 67%. And that inside this Argo observing system, basically we don't see any redundancy, except very little in the far west part of the Pacific Ocean and very northern part of the Indian Ocean, where we have lots of instruments. The density of the instruments are very dense in this area. What we can see also that the other in situ observation give little information. And that also that there are some redundancy in this other observing system, mainly because of the tropical moorings that sample at very high frequencies. Another application is for ocean state estimate. And we can, with our field, we can study the pattern of the 3D hydrographic variability and connect them with some forcing mechanism. The framework of this study here is the CMEMS Ocean State Report activities that will be presented into detail tomorrow by Karina. And again, the tool, what the GlobeUps system output, the reprocessing that we have, and the result will be soon available in the first CMEMS Ocean State Report. Again, some illustration is just to give you a flavor. I'm not going to go very much into detail in the forcing mechanism, but it's just to illustrate what we can do with our field. I took the mean sea level curve that Yanis has just presented, and with our field we can have the 3D vertical structure of what is going on in the temperature and in the salinity field. So here 2 examples. The first one is the depth time section of temperature anomalies, global means, and the second one is the depth latitude section of temperature trend over the 1993-2015 period. And we all know what we can see, that the amplitude of the warming is not spatially uniform. For example, the southern oceans show a strong trend down to 1400 meter depth. The trend is about 0.02 degrees Celsius per year. Also, what we can see is that we have a strong year-to-year variability in the main thermocline, which is mainly related to what is going on in the Pacific thermocline in response of the different ENSO events. And if we have a better look of what is going on in the Pacific Ocean, here you have again the depth latitude section of temperature anomaly for different years, starting in 1993 up to 2015, and we can see again the strong warming from year to year in the Southern Ocean. And also what we can see is the strong impact of the different ENSO event with what is going on for a La Nina event, for example, for the year 2008, where we have colder water than the mean in the first top 100 meter, and warmer water below during a La Nina event in the equatorial Pacific Ocean, and during an El Nino event, it's the reverse. Also, we have access of the 2D variability of the field. Here it's an example for the near surface salinity at 10 meter depth. Here you have the anomalies for the year 2015 compared to the 20 years mean. And we can see also the strong impact of the year 2015 El Nino event with a strong freshening in the equatorial Pacific Ocean, because we had heavier than usual precipitation under the intertropical convergence zone. Also, during an ENSO event, the intertropical convergence zone and the South Pacific convergence zone are known to move equatorward. This is why we have a salinity higher than the mean also around this structure. Also, what we can see is a quite strong negative salt anomaly for the North Atlantic Ocean, in here. And here you have the vertical structure with again a depth latitude section for the Atlantic Ocean of temperature anomalies and salinity anomalies. So we have here the fresh event, which is visible down to 800 meter depth, and it is associated also to a cold event in the North Atlantic Ocean during the year 2015. And this cold event is nicely described in the CMEMS Ocean State Report. Just a few words about the CMEMS catalog, but this has been already described by Corinne this morning. You can find our product in the CMEMS catalog. So what we have today is this that I've already described. And next April, for the next version, we will have a completely new reprocessed time series covering the 1993-2015 period. And also we will have the new product of sea surface salinity and sea surface density. With our project, we have a product data sheet, product user manual, quality information document, and also all services are available, the web map server, subsetter, and also FTP. And just to finish, I don't know if some of you are already users of our project, but if so, and if you have any feedback, please come to see us, and we will be very happy to discuss if you have any feedback on our product. Thank you.